Welcome back everyone, Patrick here, moving on to another question dealing with expanding and simplifying. So what we got to do is expand and simplify all of these terms. And notice that these are all squared binomials, meaning the binomial is in the bracket, so it's two terms that are either subtracting or adding, right? So this is like one term and then this is the second term. That's why it's a binomial. And then what we're doing is we're squaring it. So a common term you'll see for this is squaring binomials. Now, there's different ways to do this. Personally, the way that I'm going to do this, so for example, like x minus 4 squared, I'm going to do it just manually. So I'm going to write out x minus 4 times x minus 4, and then just multiply those two brackets like we've been doing in previous videos. But there's one thing I want to mention with these particular questions is that you may see formulas given in a textbook. Your teacher may go over formulas as well that they may expect you to apply. So I'll show you that as well. And for the formula, you can use any letters. Here we're using x and y and then m and n. So I'm going to use different letters for the formulas. Let's use a and b. So you can either have two terms adding and then squaring it, or you can have two terms subtracting and then squaring that. And then this over here, so let's actually just do this on the side to show you how we come up with the formula. So same thing, we just multiply it out. So we'd end up with a squared plus ab again, plus b squared. And then these two are like terms. So you'll have a squared plus 2ab plus b squared, right? So that's what this formula is going to be. And then you'll have a minus b squared. So that's going to be like a minus b times a minus b. So you'd end up with a squared minus ab. That's a big 2 right there. All right, and then minus ab again. And then negative b times negative b, the two negatives make a positive. That would be plus b squared. So this would end up being a squared minus 2ab plus b squared. Now, personally, I don't like to memorize these kind of formulas. I would rather do it manually, like I'm going to show you as well, even though sometimes with formulas, it might be a little bit quicker. I feel like that extra space you have in your mind without memorizing too much stuff does make you more flexible when questions get a little bit more complex. So I prefer to do it manually, but your teacher may expect you to take these kinds of expressions and then put them in this formula. So I'll show you both ways. So starting with the manual way, my preferred way, we would just do the same thing. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And then negative 4 times negative 4 gives us positive 16. So we'd end up with x squared minus 8x, right? These are like terms you could simplify. They net out to negative 8x, and then we have plus 16, like that. So that ends up being the final answer for part A. Now, if we were to apply it to one of these formulas, first off, which one would we apply to? We would apply to this one because there's a subtraction there, right? We have x minus 4. If it was x plus 4, we'd apply it here. And so what you just want to do is you want to see what's the a value in this case. Well, it's like the x. And then what's the b value? A minus b, we got x minus 4. So the b value is like positive 4. Right? A minus b, x minus 4. So the a is like x, the b is 4, and then all you want to do is you want to take the these for the a and b, the x and the 4, and then plug it into the formula. So you'd end up with a squared, which is x squared minus 2 times the a value of x times the b value of 4 plus 4 squared, like that. And so notice, what do you end up with? Negative 2 times x times 4 gives us negative 8x, and then 4 squared ends up being 16. So notice that you get the exact same solution that we got when we did it manually. So in case your teacher does expect you to plug these in to one of these formulas in order to get the final answer, You can do it that way as well. Again, personally, I don't recommend it. That's not my preferred method. I'd rather just do it like this. But just in case they require it, that's how you do it. So let's start off, or let's go to the next one rather. So 2x plus 3 squared, so that would be like 2x plus 3 times 2x plus 3. We'll have 2x times 2x, which gives us 4x squared. 2x times 3 would give us 6x. 3 times 2x would give us 6x. And then 3 times 3 would give us 9. 4x squared, these are like terms. That would be 12x plus 9, like that, right? And then there's no more like terms over here. So that ends up being the final answer. Also, one more thing actually I want to mention in terms of terminology. Another term you may see come up is something called a perfect square trinomial, and that's going to be mentioned more once we get into factoring. But basically what we're doing is we are taking a squared binomial, which is when it's in this kind of format over here, right? A binomial squared, as we mentioned before. And then after we expand and simplify, the expanded and simplified term, this over here or this, that's called a perfect square trinomial. So that's kind of like the result of a squared binomial. And again, this term is going to come up more in factoring because we're going to actually be going backwards from this to this, right? That's what factoring is. Instead of expanding, you're going the other way. And there's going to be sections on factoring perfect square trinomial. So that term is more common later on, but you may see that term come up. And it's basically going from this form, expanding, simplifying, to that form right there. That's a perfect square trinomial. That's a perfect square trinomial. Okay, so just wanted to mention that as well. So going back to this, let's now take this and apply it to one of those formulas. Which one are we going to apply it to? Well, we have addition, so it's going to be the a plus b squared. So in this case, the a is the 2x, and then the b is the 3, right? A plus b, 2x plus 3. And so now we just have to plug in this 2x and 3 for the a and b respectively in the formula. So we have a squared. Now you got to be careful. You got to put the 2x in brackets like that. You're squaring that whole a value, plus 2 times the a value, which is 2x, times the b value, which is 3, plus b, which is 3 squared, like that. And then over here, we have 2x in brackets squared. Remember, when you have something like this where you got two terms multiplying inside a bracket, there's an exponent on the outside. You got to take the 2 to the power 2. You got to take the x to the power 2. You got to take both of those terms to the power 2. Over here, 2 times 2x is 4x, times 3 gives us 12x. And then 3 to the power 2 gives us 9. This here, 2 to the power 2 is 4. X squared plus 12x plus 9. So notice that when we use the formula, we end up with the same solution. So now moving on to part C, we got 4x minus y to the power 2. So again, doing it manually, it's just the same process, fairly repetitive. That would be 16x squared. 4x times negative y gives us negative 4xy. Just be careful with your signs here. That would be 4xy again. When you're squaring binomials, these two terms in the middle should end up being the same. And then negative y times negative y would give us positive y squared, like that. And then these two terms, those simplify to minus 8xy, and then we got the plus y squared on the end. So that ends up being the final solution if we do it the manual way. Now, if we do it with the formula, because there's a subtraction, we're going to apply it to this over here. So it's like the a is 4x, and then the y, or sorry, and the b rather is y. Right, and so now we just got to plug in the 4x and y for the a and b respectively to the right side of the formula. So we'd end up with 4x in brackets squared minus 2 times 4x times y plus b squared, which is y squared, like that. This would be 4 to the power 2, x to the power 2. Negative 2 times 4 is 8, and then x times y, that just gives us xy right there. Then we got plus y squared, and then this would be 16x squared minus 8xy plus y squared, right? And we end up getting the same thing right here. So both ways giving the same results. So this would be 16x squared minus xy plus y squared. And then finally, part D, we have 5m plus 4n. So doing it manually, rewrite it like this. 5m times 5m gives us 25m squared. Don't forget the m squared because it's m times m. 5m plus 4n would give us 20mn. 4n times 5m would give us 20mn again. Remember to put everything in alphabetical order so you could spot the like terms easier. Then 4n times 4n would give us 16n squared. And so from here, simplifying this, we'll have 25m squared. These two are like terms, so that would be 40mn plus the 16n squared, like that. So this right here ends up being the final answer to that expanded expression. And then taking this, applying it to the formulas, notice we have a plus here, so it's going to be this first formula. So notice that the A is 5m, and then the B is going to be 4n. So then we just have to plug those in into the right side of the formula. So we'd end up with a squared, which is 5m squared, plus 2 times a, which is 5m, plus b, which is 4n, plus b squared, so 4n in brackets, squared like that. So this would end up being 5 squared m squared, distribute that exponent inside the bracket. 2 times 5 gives us 10, times 4 gives us 40, and then the mn are multiplied. Then over here we'd end up with 4 to the power 2 and then n to the power 2. So this would be 25m squared plus 40mn plus 16n squared, like that. Okay, so notice we end up with the same thing right here. So whichever way you do it, either with the formulas or expanding manually, you should end up getting the same values. If you do have a choice, I recommend going with this one just because it'll allow you to test your algebra a little bit better, because you're not always going to have polynomials that are multiplying that are going to be the same. In this particular case, we were dealing with squaring binomials, but that's not always going to happen. All right, so those are the solutions.